Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about ExcelR and I enrolled in ExcelR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He's not only focusing on theory part, he's doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, ExcelR.
Recently, I was searching for digital marketing courses online in Google, and I came across ExcelR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the ExcelR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, ExcelR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, ExcelR, for giving.
Good evening, everyone. Good evening, sir.
Good evening.
Yes, sir. Kindly take over and begin with the session.
Sure. Thank you. Good evening so much. Yep. Good evening, everyone. Nice. Okay. All right. So let us start. Okay. So yesterday we have started, a few things. We were actually, trying to understand a few things such as, concepts in NLP which is related to the AI agents. Okay. So let us continue from that, from there. Okay. So let me share the screen first. Okay. So I have a few theoretical concepts, four concepts actually. We'll finish that first, and then we'll go to the practical part again. Okay. So let me share the screen. All right. Yeah. So let's start. Right. So we are supposed to see the one-hot encoding, right? So we have seen, yesterday about, lemmatization, stemming, right? Then we have also seen the stop words, tokenization, right? Parts of speech tagging, right? So all these things we have seen yesterday. So we have four more important basic concepts. Then we'll go to some other topic. Okay, we'll discuss that. So let us first, understand what is one-hot encoding. Okay, so basically, one-hot encoding is basically converting the categorical data into numerical format. So what is categorical data? Something which can be categorized. For example, like a gender, let us say. So gender is a male and female, right? But when you are building a model, right, and to understand this model, to train the model and build the model, and to actually, the agent to understand what it is supposed to do from the model, it cannot understand this categorical language. So we should actually have converted them into a numerical format. So in that process, one important concept is the one-hot encoding. So in this one-hot encoding, basically it is going to apply into zeros and ones. Okay, so here there is two things especially. One is when we apply this one-hot encoding, in normal Python, it is a bit different to the NLP part. So in NLP, you can see that it is being framed into a matrix. So we'll see that in the practical part also, because I told you, four concepts are there. So let us try and understand these four concepts, and then let us go to the practical part. Okay. So all except that particular index, everything it is going to convert into zero. So this will identify lack of it will identify that this is the particular thing in this particular matrix. So that is the way this one-hot encoding is done. So practically, it will be more detailed to understand for you. We'll go there. Okay. So just see the examples, then we'll go to the practical part. Okay. So the example is the sentiment analysis. You can see that I love this product, right? And if you want to, do the one-hot encoding for the word love, okay? So where love is coming in the group of words, there you will see 1 and the others will be seen as 0. Okay, so here you can see I love this product. Okay, and the last you can see the what we can say, the prediction, okay, or the target variable. So here it is, in this case it's a sentiment analysis. So you will have feedback, or you can say your sentiment, whether it is positive or negative. So that will be your fifth column. So which is the love or hate, just given. Okay, it's just for an example. So you can see here, you can say love, or it's a positive, actually it's a positive. I'll change it. Okay, so it's a positive sentiment. Okay, so if you see here clearly that there are 5 columns now. I love this product, hate. So hate or love, whatever you feel, you can just put it positive. Okay, so there are 5, and since we are doing the one-hot encoding for love, right? So where love is, you will see the 1. For the rest, you are going to see 0. So that will indicate the presence of that particular word where it is in that particular location. Next thing is the spam detection. Okay, so the same way, even in the spam detection, it is going to apply the one-hot encoding. For example, claim your free price now. Okay, so it is going to identify, it is going to segregate the words. Right, we have already seen segregation is basically tokenization, right? So all as a part of, it's a step-by-step process. It's not like directly we are going to apply the one-hot encoding. So whatever we have actually seen, right? So tokenization, stemming, lemmatization, parts of speech tagging, right? So NER we have seen, right? So it's a step-by-step process what we are seeing. So in that same step-by-step process only, we are going to apply the NLP tasks. Okay, and even the AI agent, it is going to go step-by-step process. It is going to break down the words, right? It is going to understand each and everything. Then it is going to take that what it is supposed to understand, right? So the context, especially what I'm trying to tell you. Okay, so this is how actually things work when you give something to an AI agent. So next is the document classification. So text from different topics like sports, tech, politics, right? So one-hot encodes help represent keywords per topic. So like goal, sports, algorithm, tech, election, politics. So it is going to map. Next is, let us see the next important thing, which is the bag of words. Okay, so bag of words is also a very important concept. So basically this bag of words is nothing but converting the text into the numerical vectors. Okay, so this is basically, it basically ignores the grammar, word order and context. So this is a different concept coming from the one-hot encoding. So you can see that each document, sentence, paragraph, or article is represented by a vector of word counts from a fixed vocabulary. Okay, so this also we will see in action and practical. Okay, so first let us see the example part. So let's say your vocabulary is I love data science. Okay, and you have a sentence, I love data science and I love learning. So after removing the stop words, it is basically reduced to I love data science learning, because basically here even actually I is also is actually a stop word. Even that should be removed actually. So love data science learning, yeah, because already love is 2 times repeating, so it will only come once. Okay, so so this particular, even I also can be removed actually. I just edit that later. Okay, that hate and this one, yeah, I just change it. So here you can see that if you see clearly that love, data, science, and learning, only 4 will be remaining actually. So the word frequency for these particular words, for example, in each sentence, how many times that particular word is basically repeating is basically it's going to count. That is what the back of words is. For example, here you can see love is being repeated 2 times, correct? So in the sentence, you can identify now. So I is coming 2 times, love is coming 2 times. So all the rest are coming once. Okay, so the vector basically becomes I love data science learning is what the vector is. Okay, after filtering it out. In that, it will identify that I is coming twice, love is coming twice, data is coming once, science is coming once, learning is coming once. So the vector will become 2, 2, 1, 1, 1. You can see at the top. Okay, because please understand one thing, that when a model is being built, a model can only build based on numerical values. But what about the categorical columns which are there in categories, or which are there in category, right? Like the gender, right? So what about that? For example, I can say in a very simple way that for example, departments. Okay, for example, if you are having a data set of a employee record, so you can see which department is working. So it's again a categorical variable. So then what about the categorical variables if it only takes numbers? That is the reason we encode it. We encode it using the one-hot encoder. So now the categorical vectors are going to be converted into numerical vectors using the one-hot encoding. Then on that numerical vector, along with the this is basically indexer. Okay, we say that string indexing. So it is basically an indexer. So it is going to index the numerical values, and the original numerical values also will be there, no? So that and this will be clubbed into a vector and it will try to calculate. That is how actually things work in PySpark. Okay, so in PySpark it is like that only. So using the string indexer. Okay, so it is, and then you are going to use the vector assembler and you are going to put into a vector. Okay, so why I'm saying PySpark, because PySpark is the big data technology which is used by AI agents. Okay, because AI agents has to compute a huge amount of data, so they use advanced big data technology like PySpark also. Okay, so PySpark is nothing but a combination of Spark technology. So Spark is nothing but Apache Spark. Okay, so Apache is the actual distributor of Spark technology. Spark is actually written in 3 languages. One is Python, one is R, one is Scala. Okay, so basically in the industry currently more people use Spark technology with Python. So that is why that particular thing is called as a PySpark. Okay, so next thing is real world examples of bag of words. So you can see an email spam detection. You want free money now. So bag of words models detect that frequency of spam indicating words one free money now. So this will classify how many times it has actually been repeated. Next is product review sentiment. Okay, so review is great product, works well and fast. So bag of words captures frequencies of sentiment words like great, fast, well. These words patterns help a model predict positive or negative sentiment. So topic modeling in news articles. So articles use words like politics, election, government, vote, sports like goal, match, player, right? So bag of words is a vectors that makes it easy to cluster or classify these topics or dominant topics. documents by dominant topic. So this is the use. This is the use of basically using the bag of words. Next thing is the document similarity. Okay, so compare job descriptions or resumes. So bag of words allows converting each resume into a word frequency vector, measuring cosine similarity to find the best matches. Okay, so search engines and information retrieval. So machine learning codes. Okay, so bag of words uses the match user using the vectors with the document vectors. So this is how you will be returned with the scoring matches. Okay, that is how the generative tools, or based on what you have given to answer back for the AI agents, it is going to do all these things as a process. So that is why I told, for an AI agent, natural language processing is a very, 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 very important aspect. Without that, it is very difficult for the AI agent to capture and pull back the things. Next, let us see one more very important concept, which is the n-grams. Okay, so n-grams is a very, very important concept, especially when you talk about NLP. Okay, and n-grams is nothing but classifying the words which actually having a correlation among them. Okay, so this will basically identify how much of correlation is basically there between the words. Okay, so how much of correlation is there between the words? So which words come together? Which words come together? Which words have more probability of occurring? Right. So best example is when you start Google searching. Right. So it's in a very simple way you can understand. So if you put a certain word, okay, if you start searching a certain word, so which is related to that particular word will come up in the suggestions, right? That is because of n-grams. Okay, that is because of n-grams. So why it is able to push out is it is going to calculate the probabilities. So which word is has the more probability to occur for that particular word, which word has more correlation, so that is being calculated. So it's a very, very important concept, especially in text analytics or analysis, and our language modeling and feature extraction. And especially for an AI agent, this text analysis is very important because NLP is used in many areas. A few areas I've given here, like text analysis, language modeling, and feature extraction. But especially in text analysis, okay, especially in text analysis, it is very important for an AI agent. For an AI agent, text analysis is very important. So that is how the connection between an AI agent and n-grams actually occurs. So why use n-grams? So n-grams are basically used for predictive text input, which I told as Google search, spelling corrections, plagiarism detection, machine translation, sentiment analysis, and speech recognition. Okay, so these are some of the areas where n-grams are basically used. So if you see the real world, for example, if you search, I was just telling you that real world examples, you can see that when you search something, input like how to make, okay, just stop, just pause for a while and check how to make what it is showing. So it will show you a few things like make coffee, make a pasta, make a website, right? Something it will show, right? So, for example, if you want to go somewhere, right? So you will search like places to visit in, and it will show some suggestions. So based on your location, it is going to search, give a few things. It is going to suggest you, right? So like that, it is going to suggest. So if something is coming in pairs, that is called as a bigram prediction. Okay. So basically, Google uses the n-gram models to suggest the next word based on most frequent sequences. I told you that this is a real world application, what you are going to use. Okay, so based on this only, even an AI agent uses the n-grams to predict the user requests and make sure to do a certain things also. Next is text prediction on mobile keyboards. So Swift key and Google keyboard, you can see. So if you type I am, so it is going to suggest you in the keyboards, right? So it is I am going, I am fine, I am sorry, like this. It is going to suggest based on how you have actually, based upon your most typed things, right? So based upon your thing, it is going to suggest. So if 3 words are coming, it becomes a trigram. Okay. If 2 words are coming, it becomes a bigram. So spelling correction, if somebody types here, the model may compare it against bigrams like their house, their car, there. Okay, because it doesn't know which word we have actually typed, so it will try to rectify with the nearest word. Okay. So next is chatbots and voice assistants. So book me a flight. So trigram based models understand this as a common sequence and fetch relevant intent. I was just telling you that only, that your AI agents will do this. Okay, because your voice assistants are basically AI agents. Correct. So it is going to find the common sequence and fetch the relevant intent. Next is speech recognition. So audio to text conversion basically benefits from n-gram probabilities to decide between recognizing the speech or wrecking a nice beach. Like a nice beach. Next is text summarization and sentiment analysis. So bigrams like not good gives a negative sentiment, which single word good unigram would actually miss. So, final thing is like n-grams are essential building blocks for many NLP tasks. They model local word dependencies and are widely used in real-world applications like autocomplete, spell check, machine translation, and much more. Next, we'll see what is TF-IDF also. Okay, so then we'll go to the practical. It will be 4 concepts. We'll finish this also and go to practical and then come back. All right. So TF-IDF is a very important concept in NLP. So it is term frequency inverse document frequency. Okay. So it is like a numerical statistic which is used in NLP. So it is basically its job is to evaluate how important a word is to the document in a collection. Okay. So document in the sense here a group of text. Okay. So that particular group of text we are calling it as corpus. Okay. And how this group of text is very important. Next is it's one of the most widely used techniques for text mining, document ranking, information retrieval, feature extraction for machine learning. Okay, so these are the few things. Next, this is the formula for TF-IDF, how a TF-IDF is basically calculated. Okay, so there are 2 things. One is TF and one is IDF. Okay, here also I've mentioned. I'll come there. Okay, yeah. So basically the TF is nothing but the term frequency count of the T and D. So what is that T and D is? First we'll see that TF. Okay, so I told you, TF and IDF. It's a multiplication or a combination of both TF and IDF. So basically what is TF is number of times the term appears in the document divided by the total number of terms in the document. This is basically like a probability formula. Term frequency formula is nothing but like a probability formula. Number of favorable outcomes divided by the total number of outcomes. Remember somewhere? Yeah, basic probability definition. Yes. So your TF is the same. Okay. So it is basically dividing, giving you the count. Okay. Which is basically appearing in both. Okay. So it is basically a count of, the number of times the term appears divided by the total number of terms in the document. That is the one. Next is the IDF part, inverse document frequency. IDF is nothing but inverse document frequency. Now, what does an IDF do is it calculates the logarithm of the number of documents in the corpus divided by the number of documents corpus that contain the word or the term. Okay, so this is what it is going to do. Okay, so that is why the formula is like this. Okay, once this is calculated, the next thing is you can see here. So it is basically going to calculate how many times or how much of importance that particular word is actually there in that particular corpus or that particular group of text. Big chunk of text is basically called as a corpus. Okay, so this is the formula once again. Now, the real world analogy, how you are going to understand this like a common person, if you say, okay. So those who are well equipped in NLP, if I say formulas, this, that, and all, it will be good for you. But how as a common person, because you're learning this all for the first time. So how you can take this, how you can understand this is what we are going to find out. So here you can see that imagining you're scanning thousands of new articles. Words like the, is, and appear everywhere, so they are less informative. Those are basically stop words that you already know by now. Next is words like inflation, quantum, Elon Musk appears in specific articles. These are more informative. So what happens like this is, what happens now is TF-IDF boosts the weight of rare but meaningful words while downweighting the common ones. Okay, so that is why what will happen is the words which are very important will be trained more and words which are less important will be trained less. So this will help you to understand the words in a better way and a faster way also. Okay, so this is about, we'll come to the word embeddings later. Okay, so this is about the TF-IDF. Okay, so now let me share the Python screen. Okay, so yeah, we'll just see the Python part, practical part, and then we'll come back to word embeddings. Okay. Can see question. Just a minute. It works like a Bayes theorem formula. That is not exactly Bayes theorem formula. That is just a basic probability formula, Harsh. It's a basic probability formula. It's not exactly Bayes theorem. Bayes theorem is a bit different actually. Okay, so any questions if you have, you can just post. In the meanwhile, I'll just share the screen. Yep. One hot encoding. Yes. One hot. Yeah. But all right. So I've shared. So you can just check. Okay. All right. We'll start this. Okay. So we'll start with the one hot encoding. Okay. It's not going. Okay. Okay, all right. So we'll see this. I'm not able to. It's not hiding. Okay, let me finish this and I'll close the sharing and then I'll share it again. Okay, so I think you can see the screen now. All right. So first, let us do the one hot encoding part. Okay, and for one hot encoder, the most important thing is to take the ExcelR. Okay, so ExcelR not pre-processing. You are going to take ExcelR is nothing but the machine learning part. Okay, so it's a machine learning library in Python. Okay, so it is used to apply the one hot encoder. Okay, and as I told you that how the one hot encoder works. So this is the sentence. Okay, so this is a vocabulary, and this is the sentence you can see. And when we apply this one hot encoder, okay, and here you can see import numpy as NP, right? So this is basically numpy is nothing but numerical Python. Okay, and here you can see that we are applying the one hot encoder. Okay, so you're applying the one hot encoder and you can see the output. For example, for each one you can see, for example, for I, okay, for if you see I, you can see where I will be, it will be marked. Okay, so here we are taking that for I, for love as well as data. Okay, so we are putting the one hot encoding. Next thing is the vocab. Here you can see that I have given a corpus. Okay, So in the corpus, I have mentioned I love data science, I love AI, science loves data. So here you can see that you are using the split function. Okay, so dot split, I think we have used it yesterday also. So you are pretty much aware of it. So split function will basically split something, whatever you have actually given. So why we are using the split function is to manually split into tokens. This is basically a manual approach. Okay. Now, when you split, you are going to identify the words in a separate way. So this is how you can find the vocabulary also. Here we have given the vocabulary, and we have given the sentence. But in reality, that is actually not possible. Okay. You will not be knowing that what is the vocabulary in the sentence. Sorry, in the group of words or the corpus. So what will happen is you can also identify the vocabulary by using this particular split function. Okay, so this is also one way. So both the ways I have mentioned, because it is not just about it is not just about the one way only. It is also the other way around also. So it is also important for you to identify that how you can actually get the vocabulary part. Okay, let's run this again. Yeah. So next is creating the mapping, index to mapping. Okay. So index to mapping, I told that when you map from one index to the other, now for one-hot encoding for the data will be, if you see here, you can see the vocabulary. Okay. So in the vocabulary, you can see that data comes in the second place. So you can identify one in the second place. Now, just see this vocabulary and you can see the map. So for data, it will be 1. If you give for love, it will come 1 in the fourth place. Okay, loves will come here, science will come here. AI, if you give, it will come here. Okay, that is one thing. Next, after that, next is encoding all the things. Now, wherever I you can see, it is going to come. Okay, here it is somewhere else, correct? Yeah. So I is going to come, and then you have love, then you have data, and then you have science. Okay. Next is applying the one-hot encoding again. Okay. This is one more example. Okay. So this again with the one big sentence. It is not really big. It is like somewhat. It is somewhat big. Okay. NLP enables machine to understand and generate human language. It powers applications like chatbots, translation services, and voice assistants. That is why only we are trying to understand how and what assistants or how an AI agents understand what a human being is actually asking it. Okay, so as a process, it is going to happen in NLP. Okay, so that is one thing. And here you can see in the bigger text, you can see the we are applying one function and this find all. So this will basically, this is a standard syntax. Okay, this particular pattern. Okay, this you need not change. Okay, so /b/w plus /b. Okay, so if you give that, it will remove the punctuation and it will lower the case. Okay, so even natural you are going to get as n small. Okay, so that is happening actually by this particular function. Okay, that is actually cleaning the data and removing the punctuation actually. This is basically converting into lowercase. So whatever are there, it is going to give you as a tokens here. You can see. Next is the unique vocabulary. Okay, so whatever the words are unique, it is going to identify in that particular sentence. Okay, so something is repeating multiple times, it is not going to consider. Okay, so that is what the unique vocabulary or unique words is basically about. Okay, so that is the next one which we have done. Okay, next is applying one-hot encoding for the sample data. So in the sentence, so we have multiple words, so the matrix also will be a bit bigger. Okay, so when we give that particular word, for which word we are going to find the one-hot encoding, it is going to identify and it is going to give you. Okay, so that is how we are going to basically encode. All right, so coming to the next part is putting it in the frame of a pandas. So pandas is nothing but library in Python. Library in Python, which is basically used for, in a simple way, for data frames. Okay, so data frame is nothing but a table. Okay, a table format is basically called as a data frame in Python. Okay, so for that, whatever features are there, for all the features, it is going to show you the encoded values in the form of a table. Okay, so like this, it is given now here. Yeah, like this, it is giving no. So instead of that, it will give like this, because the table, this words are more in this case. Okay, so 19, no, 0 to 19, so total 20 words are there. Here you can see 20 words somewhere here. Yeah. 20 vocabulary size for the same only. For that same number of words or vocabulary, actually it is called as not words, vocabulary. This is what the data frame we have built. Okay, yeah, so that is about the one hot encoding. Okay, so just a minute. So I think this, yeah, I'll download this. Okay. So let me just close it and share. I'm not able to. That Zoom one is coming in the middle. Yeah. So let me share again. Yeah, I think you can see now, right? So the 8th one. Yeah. Right. So next, let us go with the thing called as bag of words. Okay. So we'll see the bag of words. We have seen the concept of bag of words also. And for the bag of words, the most important thing is this is basically a type of matrix conversion only, right? So based on the vocabulary, it is going to convert into a matrix. Okay. So this is how, an AI agent will actually understand the data. Now you understood now how, things work internally. So it is going to do all these things, that happens pretty much faster. Okay. So that is why, when you do, right, when you ask something, within a few seconds, you're going to get a reply. Okay. Now to convert this into bag of words, okay, so we are going to use something called as count vectorizer. Okay, count vectorizer. Okay, now this count vectorizer is inside the ExcelR library. Okay, so it will be inside the ExcelR library. Okay. So yeah, I'll just put like this, or else it will be a bit confusing for you. Yeah, I mentioned one particular thing here. Yeah, we can just go through. So here count vectorizer is basically a tool from scikit-learn. Okay, so I told you, scikit-learn is basically wait. Yeah, it's better to be in the up. Yeah. So basically, this count vectorizer is a tool or a module, I can say, inside the scikit-learn. Okay, and this scikit-learn actually tokenizes a collection of text documents and builds a vocabulary for all the unique words that then counts the frequency for each word. Okay, so how many times that is again repeating, it is going to count. Okay, so even this also we can put like this to save some space. Okay, so now see, looks good, right? Yeah. So that is why we are using this count vectorizer. Okay, and this is inside the sklearn.feature_extraction.text. This is the module, because sklearn is basically a library. Okay, did I mention here? Yeah, I have mentioned. Good. Okay, so fine. So sklearn, scikit-learn is a library. Yeah, feature extraction is a module, and count vectorizer is a function. Yes, I've mentioned perfectly. So you'll be able to figure it out easily, because I'll be sharing these files with you, so you can practice these upon. So just a minute. Yes. So this is the sentence what we have. Okay. And in the sentence, especially, we are going to understand that once we apply this count vectorizer and how this is basically converting or see fit underscore transform is nothing but see one thing you can understand is basically transform is used for prediction. Okay, transform is not transformer. Don't get confused. Okay, that is transformer. That is different. Okay, so this transform means which a function which is used for prediction. Fit is basically a function which is used to train the model. Okay, and whatever we are applying here to find the count of words, it is going to give you as an array because I am converting the output into an array. Okay, so array is nothing but a data structure in Python. Okay. So many things, no extra lines we have put. Sorry. Fine. So that is what it is, and you can see the vocabulary first. Okay, so you can see the vocabulary for the words inside the sentence. It has given analysis and data. Only once you will get vocabulary will not be repeated. So analysis and data, exciting, for, fun, great, include. So all those things you are going to get. All right, and you can see the bag of words matrix for the given words. Okay. Now let us go to the next one, which is bag of words into a data frame. Okay, so like what we have done in the the previous one. Okay, so it's very similar. Now let us go to the next part, which is for the bigger text. Okay, so here we can see that we have a bigger text. Correct. So I've put a bigger text also, so that you'll be able to understand. So this is in this corpus you can put anything. This is basically could be news, reviews. Okay, so you can just copy a review from a Flipkart or Amazon, something like that, and you can actually find this bag of words matrix. Okay, I'll be sharing with this, so you can apply this model for that. Okay, so you have a very interesting text, which is NLP is a fascinating field of AI. NLP enables machines to understand, interpret, and generate human language. Applications like machine translation, speech recognition, and chatbots. Text classification is a core task in NLP. Useful for spam detection and sentiment analysis. Modern NLP uses deep learning models like the transformers and BERT for language understanding. So this is the text. Now let us do the count vectorizer for this. Okay, let us also apply the stop words, and then let us use the vectorizer to fit and transform. Then let us convert it to an array, and then let us extract the words. Okay. Now you can see that the bag of words matrix, you can see all those words directly put into a matrix, because I have not asked like how it is here. If you see here, see, I have given display the vocabulary also. So display the vocabulary I have given, but here I have not given. So directly the bag of words matrix I have given. So you can see the matrix which is coming as an output. Okay. So yeah, that is what it is. And you can see the length of the words. Okay. And here I have not put, here you can see. Because that was, here it was less. But the problem here is it was more. You can see here it is showing 39 columns. So there are 39 words, actually 39 words, or you can say, yeah, should not say words, it is vocabulary. Okay, so that vocabulary words are these. Okay, so these words only, it has been put into the bag of words matrix. Okay, now next thing is applying the bigram, trigram, and all. First let us try to. Okay. So wherever it fits, we'll try to adjust. Okay. Yeah. So now you can see that we are including n-grams. Okay. So we are including 1 gram, 2 gram. Okay. So 1 gram is basically called as a unigram, and 2 grams is basically called as a bigram. Okay, so we are implementing all the bigram and trigram also. Sorry, unigram and bigram also. So now let us apply the for the text. Let us apply the count vectorizer first, and then let us fit the bigram. Okay, so for what we are fitting the bigram is nothing but the corpus. Okay, so corpus is the corpus what we have given here. The text data which we have given is the corpus. Okay, and we are fitting for the corpus and we are converting into a data frame. So now for each words, it has converted into bigrams and unigram. Okay, so that is how it has actually calculated. So this is basically about the bag of words. Okay, so let me download this also to share it with you. Okay. Yeah. So let me stop the sharing. I'm not able to view those the upper part because of the that is why only I'm stopping the sharing. I'll just share it back. Yeah. Okay. Next we'll go with the n-grams. Okay. So properly we try to apply the n-grams now. Okay. Now you can see that. Yeah. So now we are basically using the NLTK library. Okay, and we are trying to apply the word tokenize and n-grams. So this n-grams function will be inside the util. Okay, dot util. Util is nothing but the utilities. Okay, it's a utility module inside the NLTK library. Okay, and here you can see the text. I love natural language processing. Okay, so I've given a particular text here. Okay, it's not taking. Okay, yeah. No problem. Right. So you're pretty much aware of this punct and punct tab, correct? And then we are applying this tokenize. Okay. So we are applying the word tokenizer, and then we are segregating into bigrams and trigrams. Okay. So now the next thing is whatever words should be formed together, it is going to show you. You can see the first output, bigrams. So I love is one word. Again, love and learning is one word. Like one word in the sense like couple, because it's a bigram. No, bigram means two words together. So love, learning, then learning, natural, then natural language is again couple, then language processing is one couple. Now, if you use trigrams, okay, it is I love learning is one, then love learning natural is one. Okay, love learning natural is one, and then learning natural language is one. Then natural language processing is one. So it will stop because you cannot leave that word and go to the next one. So it will stop near natural language and processing. So that is basically called as a bigram and a trigram. So that's why we basically call it as n-grams. Okay. Next is using without using any external libraries, just creating bigram using pure Python. Okay. Now the sentence is given. We are going to create a user-defined function. Okay. So we are going to give a user-defined function, and then we are going to find the bigrams and trigrams. Okay. So this is basically just by applying it into tokens. Okay. So length of the token we are going to take. Okay. So we're just taking one particular for function or a for loop. Okay. So in looping we have for loop and while loop. So like that we are taking for loop, and we are going to generate the bigram and trigrams. Okay. So this is using pure Python. Okay. So I just wanted to show you that also, because basically if why? Because basically if we have to do we can actually I would say it is always better to apply using the original NLP things. But okay, there is also one more method using the pure Python. So that is why I am showing you that also. Next thing is using the third method, which is the count vectorizer. So this is basically used in the machine learning. So this count vectorizer will count the number of grams, which is bigram or trigrams, whatever you want, and it is going to vectorize and fit into the corpus, and it is going to give you the output. Okay, so that is the main thing, how a bigram or a trigram actually works inside the using the machine learning library, which is the ExcelR. Inside that you have this count vectorizer. Next thing is applying n-grams on bigger text. Okay, so applying on bigger text, there is a lot more bigger things which you can actually do. Okay, so for example, like the calling out so many things or so many libraries. So here you can see a group of libraries which we called. Okay, so first thing is the NLTK. Okay, so NLTK is basically a natural language toolkit. Then we have a utility module which is used for n-grams, and then we have the tokenize for the word tokenize. Then we have the corpus for the stop words. Then we have collections for counting the number of words which are repeated. And we have already used this counter function, right? You remember. Next is a matplotlib for data visualization. So this is how we are going to do. And next part is to call out this punct and stop words libraries or required resources, I can say. So now we are giving a sample text, which is the bigger text. Okay, the same kind of text what I've taken there. The next thing is step 2, which is basically tokenize. Okay, and basically we are starting to tokenize. So first thing is for pre-processing, we are basically tokenizing it. Okay, so word underscore tokenize function will tokenize. Okay, then we can apply the stop words removal. Okay, that means removing the words which are not useful, right? You are already aware of the stop words is right, the okay, and to, on, all these things are stop words, so those will be basically removed. Okay, so that is what you can see in the output. The stop words are basically removed. Okay, so coming to the next one, which is the bigrams. Okay, so we are basically now generating the bigrams. Okay, and here you can see that we are using the bigrams and we are using the trigrams. So if you give the list n-grams and you mention that it is 2, it is going to consider that it is a bigram. And if you give the list and n-grams function, and if you give 3, it is going to consider as a trigram. Okay, so that is how it is going to consider. The next thing is term frequency, right? So basically term frequency is nothing but counting the number of frequency for the words. How many times that particular word is actually repeating. Okay, so if you display the top 10 frequencies, you can see that you have so many. Okay, and as a couple, how many times it is actually going to process is what it is going to count. So it is basically counting of number of bigrams and number of trigrams. Mostly it will be 1, sometimes it might be 2 also. Okay, in only one instance you can see it is 2. Natural and language is coming twice. Apart from that, everything is only coming once. Okay, so that is how bigrams and trigrams actually work. Next thing is basically visualization. Okay, so basically we are trying to visualize the data. Now here you can see the top 10 bigram word and top 10, you can see that only natural language is coming twice. Okay, all others are only once. You can see in this data, no? Yeah, language and processing and NLP and field, everything is only coming once. The only thing which is coming twice is natural and language. Okay, so that is what it is. Okay, so here I have only plotted for the visualization of a bigram. So the same thing you can apply also for the trigram also. Okay. Yeah. All right. So I'll share this also. Okay. Just give me a minute. I'll share the screen again. Yeah. So next we'll see the TF-IDF. Okay, let me share my screen back. Yeah, we'll finish that TF-IDF and then we'll go for a break. Okay. So it takes another 5-10 minutes only. We'll finish that. Okay. Then we'll go for a break. So I'll be feeling all those 4 concepts are done. Okay. Yeah. So let me. Sorry, just let me close this. Only 3 will run actually. Okay. Okay. So Tran, yeah. Right. So we are ready and ready to. Okay. All right. So the first thing in that TF-IDF is basically finding out the term frequency and the inverse term frequency. So I showed you the formulas now. So those formulas will be applied here. Okay. So that is why you need not apply. You need not remember the formulas, but you should just know that how the formulas actually can be applied. Okay. So on what basis it is going to actually take. Right. So in that way, I would say that you just have to at least remember that, okay, this is the format it is going to. So bit by bit formula and all, it's not required for, many of you to identify. Right. So to apply this TF-IDF, which is the term frequency, inverse term frequency, inverse document frequency, you need this particular function, which is TF-IDF. Okay. So the only thing in that is T is capital. Apart from that, everything is small. So TF-IDF vectorizer is what the function which we are going to use. So that will be the same function, which is what we have used for engrams. All right. So which is basically the ExcelR.feature_extraction.text. Okay. So basically this extraction.text is feature_extraction is basically a module. Okay. And here we are taking a corpus. Okay. So corpus is nothing but a corpus is nothing but a text. So you can see one interesting text. ChatGPT is a great chatbot developed by OpenAI. ChatGPT helps users with a wide range of NLP tasks. Natural language processing is a crucial part of AI, and machine learning and NLP are transforming the technology. Okay, so it's a basic sentence about NLP, and we are applying the TF-IDF now. Okay, and here you can see when you apply the TF-IDF function, right, you're also giving this, showing the classification about the, showing the information about the TF-IDF function. Okay, and you can apply this stoppers, obviously, and we are using the vectorizer to fit and transform the corpus. Okay, and after that, it is basically converted into a matrix. Okay, and you can see the matrix with the probabilities. Okay, so what is the chance for that particular text to occur? Okay, and how important, basically TF-IDF, what it actually does in the document. Okay, in the document, how important is that particular word in that particular document or a corpus? That is what your TF-IDF is actually going to give you. Okay, so these are the probability values. Okay, so right, I'm not expecting you guys to remember the coding, do the coding part. Don't worry. Okay, so I'm just showing you because this is how things work. Okay, so if you're interested in the long run, you can learn. That is up to you. Okay, but in a smaller perspective, broader perspective, if you think, it is like how things work. Okay, so this is like a working inside an AI agent. How it uses NLP to understand text and give you reply and understand what actually these agents are actually doing. Okay, this is just for your understanding. Okay, don't take too much of tension. Okay. Okay, no problem. No need to, I'm not expecting you to start, start open Google Colab and start, doing coding. No, it's not that. Since I can only explain through coding part, I'm actually showing you. Okay, this is how it works, right? Even though how examples I take, it will only be theory part. It will only be like a theory part. So if I show you the code and how things work, if I show all the, it will be somewhat, you'll be able to figure it out. Oh, this is how we write. This is how you can get the output. Yeah, like that you'll be able to figure it out. It's not like want you to code and I'm not expecting that. Don't worry. Okay, that is completely up to you. So the next thing is you predicting the top n words. Okay, and here we are taking the document for the TF-IDF. Okay, so sorting the words into descending order of importance. Now you can see that the maximum probability in the words is basically 0.46, which is the word for the word chatbot. Okay, so this and we have taken the document 1. So you can see the probability of words, right? The importance of that particular word is shown in the probability that particular sentence in that particular document in the form of a probability. Next, we'll go to the next project. Okay, so here we are going to see that we are going to apply the TF-IDF on a larger corpus. Okay, we are going to apply into a larger corpus. Now you can see that, okay, how you can actually apply this TF-IDF. Now you can see that we have a bigger text. Okay, bigger means very big. Actually, you can see the text. Okay, so it contains basically multiple paragraphs. Why I have taken a bigger text is sometimes you will see this amount of reviews, this amount of prompts which are given. Okay, so based on that, it is basically used for maybe building the term frequency and inverse document frequency. Okay, now so using this bigger text, what we are going to do is, first of all, we are going to call all the necessary libraries. Okay, sklearn for feature extraction, pandas and numpy, then using the NLTK, then using the matplotlib for visualization, and cmon also for the visualization. Now the next thing is, what we are trying to do is, we are going to initialize the vectorization. Okay, and for this vectorization, okay, so we are going to fit and transform. So already you have seen that particular thing, and term frequency, inverse term document frequency we are applying, which is TF-IDF. Okay, so this basically removes the common words, all the English words, which because we are giving the removing of stop words, ignores the terms that appears in more than 85% of the documents, helps filter out words in a uniformity manner or an uninformative manner. Adds 1 to the document frequency to prevent zero division, especially helpful for rewrites. So next, applying the vectorizer for fitting and converting into a data frame. Okay, so now here you can see that this is basically converted into a data frame. You can see the probability, okay, for the words. So there, if you see 0, right, it means that for the document 1, the word accessibility is of no importance. Okay, for example, algorithm. So in algorithmic word, if you can see, for the first 4 documents, it is showing it has 0 probability. So for the 5th document, it is showing a probability of 0.23. So what does it actually tell you is, for the 5th document, the algorithmic word is of 0.23 importance. Okay, so that is what it is basically is. Okay, so the next thing is getting the top words. Okay, and here you can see for the top words, okay, you can see the probabilities of the top 5 words. Okay, next is visualizing words using the, now visualization, we are going to use the cmon or matplotlib for the data visualization. So now you can see the visualization part. Okay, so the top 5 frequencies. Okay, and the next thing is in the document 5, you can see the 4 documents here. For document 1, yeah, now you can see. I just scrolled it up. The scroll is bar. Yeah. So for all the 5 frequencies, you can see for first document, you can see the frequency. Okay, and next thing is for the second document. Okay, and next thing is for the third document, and this next for the fourth one, and next for the fifth one. Okay, yeah. So this is what it is. Okay, so let me run it again. Sorry. Okay. Yeah. All right. So this is what it is. Attendance link. It will not be shared now. Okay. So these four I'm sharing it now only. Okay. I'll not share it later again. You can see I've shared all the four. So 10, 7, 8, and 9. Okay. All the four files I've shared. Okay. So yeah. Okay. So I've shared the four files. You can download it. These are again. No, you can give it from your place. It's an online MCQ test. Check. It's an online MCQ test. Yes, yes. Okay. So yes, actually, I've not asked you to ask any doubts. Even I was actually in a flow, so I also didn't give you much of time. But it's okay. No problem. Take a break and let us come back quickly. And in the break, if you have any questions, you can probably post it in the chat. Okay. So it will help me once I'm back from the break. I'll just first answer your questions. Then we'll go to the next part. All right. Manasvi, the files will not open directly in your laptop. Okay, you have to put it in your Google Drive, then you can open. Uh, it is a Python file. Okay, it is not just a it's not like a PDF or a Word document. I've already told you this. Probably you've not heard. Last couple of days I'm telling you already. So it's actually a IPYNB file. Okay, you can only open, you can only import into any application. Yeah, so any application where it is reading IPYNB files, or you can only open it in, you can paste it in, sorry, you can copy it and paste it in your Google Drive, and you can open there. So even I'm opening it from Google Drive only. You can see that. Okay, so any other questions? Okay, yeah. All right, so let me continue then. Okay, so this we were actually discussing, right? So TF-IDF is done, right? So we have to talk about the word embeddings. Okay, so word embeddings is basically representing something basically into a vector format. Okay, so a continuous vector format. So something basically represented into a continuous vector format is basically called as a word embeddings. Okay, so this this particularly this actually not just like a one hot encoding or a just not building like a bag of words. This is not like that. So you have seen giving as a indexing like a bag of words or one hot encoding you have seen, correct? This is not like that. This is somewhat different. Okay, this is basically a model kind of building. Okay, so in a easier way to tell, this basically builds the relationship, or it will identify the relationship between the words. This is a very simple way to understand. So this is basically a it tries to, yeah, I've mentioned here, right? So it basically captures the context, and it is actually building the relationship between the words. So this is the main aim of what a word embeddings actually does. So next is how word embeddings are usually used. And you can see that there are a few things, for example, like models, a few algorithms, or model buildings like this word to vector. Okay, so this was the initial model, which is a very, very important model when this particular generative AI and agentic AI actually started in the market. So word to vector, glove, fast text. Okay, so then the advanced it was step by step. Okay, development is happening, and more now the more focus now was into the contextual embeddings. So in that part of contextual embeddings only, one important embedding is a BERT. Okay, one important embedding is BERT. Okay, so BERT transformer we are actually using. So I've shown you an example also, the implementation of a BERT transformer. So that is what we are actually in. So word to vector, glove. So already we have actually used those in the past. Now we are mostly using into the BERT transformer. So next is how these are actually used. Especially this word embeddings are especially used in a certain fields like the text classification, named entity recognition, machine translation, sentiment analysis, question answering, chatbots, and language modeling. So these are the few areas which this particular word embeddings is basically used. So the next thing is, what are the benefits of using this word embeddings? What are the benefits we are going to get? So this basically reduces the input dimensionality, captures the semantics and syntactic patterns, in the data helps models generalize better, helps downstream NLP tasks to perform better. So what are the limitations? So there are also limitations for this, which is embeddings. Static embeddings can't distinguish polysemy. Bat, which is a animal, versus what is a, so we say the word in cricket also, right? So cricket bat. So can encode biases from the training data. So contextual embeddings are more powerful but computationally expensive because they are basically static. That is why only from word embeddings, from because this word to vector, it takes word embeddings are good. Okay, so in that a few things, algorithms like the contextual embeddings like BERT. So once these came, the understanding the context, right? This has actually developed. So few limitations which are already existing in the before models of word embeddings have been overcome by this BERT transformer. So I can say transformer. Okay, in the transformer architecture, BERT is one particular transformer. Okay, yeah. So actually, BERT is one model actually. Okay, so I cannot say transformer. BERT is actually one model in the transformer architecture. This is the correct word. Okay, I have to give you the correct information. No? Yeah. So next is word embedding revolutionized NLP by allowing machines to understand the meaning and relationship between words. This was the most important thing, which was actually important for the AI agents to actually understand that what is the context, what is the scenario. So what happened is they laid the foundation especially to the modern NLP pipelines and a must-know concept for anyone working in AI and language understanding. This is the main scenario in which why even I have taken up NLP to explain to you a few things, especially which is relating to the generative AI and the agentic AI. Next, let us see the concept of word to vector. Okay, so word to vector is basically a neural network. So neural network is nothing but network which is based upon the concept of neurons. Okay, so something which is based upon neurons. And what happens is this basically converts into vector representations, or we can say embeddings. Okay, so which are having similar context. Okay, so this was basically introduced by Thomas Mikolov. Okay, Thomas actually, there's not Thomas also. It is Thomas Mikolov at Google in 2013. Okay, so this was I'd say much older than the transformer. Okay, so once all these models came, then after that you have actually seen the transformer in action in the year 2017. So what is this word to vector actually does? So the focus was on the context-based learning. Okay, so basically if you include a corpus sentence like the king rules the kingdom, the queen governs the empire. So word to vector will basically learn that king and queen appear in the similar context. So their vectors are close by. So king and kingdom often co-occur, which is the strong association. Next thing is what makes word to vector so special. So basically word to vector captures the semantic meaning and relationship between the words. So basically the vector arithmetic meaning is vector is king minus vector man plus vector woman is equivalent to the vector queen. Okay, so here it will add, it will subtract. So basically vector is nothing but a representation of all the scalars into one particular form. In the matrix form is what vector is. Okay, so here it is minusing the king who is a vector and minus the man. So so basically the king and the man will go cancelled out and you will be left with the woman vector, which is the queen. This is how it is going to mathematically calculate, because what happens inside is the mathematical operation only, right? So next is examples of embedding space. So there are basically 2D vectors and 3D vectors. So you can see that king, queen, monarch are somewhere nearby, and king and banana are somewhere apart. Okay, so this is what this word to vector will identify. So this will identify that which words have similar, or we can say which are very nearby, which words are far away. that context it is going to build upon. Next is what are the advantages of using this word to vector. So the advantages are basically semantic similarity. This basically reduces the dimensionality compared to the one-hot encoding, and it tries to understand the analogies as well as compute the deep learning models. So these are some of the advantages, and okay. So these are some of the advantages, especially when we talk about the word to vector. Okay. Next, let us see that what is exactly NLP when we perform inside deep learning. Okay, how this is actually related to the deep learning part. So this entire structure of what we are learning as natural language processing, which is basically used by everyone in the AI, especially the agents, right? So generative AI, right from the generative AI agents, agentic AI, all these people, right, who are practically, components inside the AI, right? So these are basically used in, you have seen the use cases and applications a lot. So like text summarization, question answering, machine translation, text classification, name identifier. So you have multiple applications in which you can actually apply. So let us see the key components, and you have seen the word embeddings, right? So in that word embeddings, you have seen the word to vector, glove, and fast text. These are the three things. And after that development of these three things, next the generation went to the next part, which is the RNNs. So RNN is nothing but the recurrent neural network. Okay. And this basically RNN is used for sequential data. Okay. And the main important components of RNN is basically nothing but the LSTMs. So LSTMs are long short-term memory. And then we have something called as GRU, which is gated recurrent unit. Next is the attention mechanism. So this is what the entire concept of transformers was actually relying upon. So on the attention mechanism only, the transformers were actually built. So we have already discussed on that. So this attention mechanism helps model focus on the relevant parts. Then this also improves the performance in translation, summarization, etc. So next is the transformers. So revolutionized NLP, which was introduced by Vaswani in 2017. The core idea behind this is implementation, or the research into BERT GPT T5 models. Okay, so this was self-attention. Okay, because before it was attention mechanism, now it is self-attention plus positional encoding, which has together brought the concept of a transformer into the industry. Okay. So the next part is applications with the NLP. Now you can see voice assistants, translations, chatbots, and everything, fake news detection, and much more to the part. Next is the challenges. Always ambiguity in the language. So how much ever we are going to understand the context, still sometimes the understanding the context has always been a difficult thing. Okay. And sarcasm and irony detection also, that is also one of the areas. And holding out the context in a longer documents, so that was also one of the challenges. Okay, so even that was also challenges, especially when it comes to the especially when it comes to the these analysis of documents, and in that holding this context for a long time is always been a bit of a challenge. Next is data bias and fairness, then computationally expensive models. So basically you can see that NLP in deep learning is at heart of many AI powered applications. So with models like BERT and GPT, machines are becoming increasingly proficient in understanding and generating human-like text. Okay, mastery of NLP with the deep learning opens doors to develop cutting-edge applications in virtually every domain. Okay, Because why I'm telling you all these things is you are trying to, whether you will build an AI agent, right? We are building one, but it's not just about building, it is about also using it. Okay. So maybe somebody else builds, we will use it. So even to use a certain things, you need the contextual or the conceptual understanding of how these things actually work. Now let us see a small difference between an ANN and RNN. Okay, and ANN is nothing but an artificial neural network. Okay. So ANN is the artificial neural network. Then we have RNN, which is the recurrent neural network. Now, what are these two, right? They have neural networks in common, but they are different. Okay, they are having almost similar kind of name, but how they actually work is actually different. Okay. Now, let us see the structure of an artificial neural network. So, a neural network is nothing but which is depending upon something called as a neurons. So here you can see that the structure is basically a feed-forward network. A neural network is basically a feed-forward neural network. Then it is basically used inside the classification, regression, and the image recognition. Okay, and I'll not go too deep, Harsh. I'll not go too deep, okay? Because this is not exactly an AI ML class, okay? So I'll not go too deep. What exactly I'm going to do is how much is sufficient. That part is I'm going to uh, you know put in there. Okay, not everything. Okay, yeah, not everything. Just for making to understand the outline structure for how and how it is related to an AI agent. That's it only. Whatever is relating to an AI agent, that particular thing only I'm covering. Okay, yeah. All right. So yeah, let us continue. Yeah. So we were discussing about this ANN, artificial neural network, and especially when we talk about ANN, ANN is basically a model which is based upon the neurons, and this is basically used for regression tasks, classification tasks. Like this, it is going to be used for multiple things. Okay. So especially the key differences between your RNN and ANN is nothing but RNN is used especially for sequential data, or you can say sequential tasks, something which happens in a sequential order, like the time series data, right? And sales over a time, right? So something which happens in a sequence, like the text, okay, text analysis. Everything is basically done using an RNN. Okay. So next thing is let us see what exactly is an RNN now. Okay. So RNN is basically which basically used for which is an unstructured data, especially. Okay. So or we can say not especially unstructured, but only also used for structured, like the time series data, right? Sequential approach, like a text data. Text data is again an unstructured. So it's basically a combination of both, okay, structured and unstructured. So RNN actually has the aspect of remembering the past data, or you can say remembering the things in the model. Okay, so as a part of this RNN only, we had one of the models called as an LSTM. Now let us see the memory capability. Okay, ANN, each input is processed independently, no concept of memory. But RNN is not like that. It has a hidden memory or a hidden state. This is updated at each step. Okay. Now, enhanced RNN variants, you can see when RNN is enhanced, enhanced is nothing but the upper versions, or you can say, trained, more improvised versions. So you can see, two things. One is the LSTM, the other is the group. Okay. So LSTM is long short-term memory, which is designed to overcome RNN's vanishing gradient problem and handling long-term dependencies. Okay. And the next thing is group. So this is the gated recurrent unit. Okay. So this is basically a simplified version of LSTM with comparable performance. Okay. Next thing is, what is RNN? So RNN is a recurrent neural network, which is basically designed for a sequence of data. So especially it is used in NLP because because NLP is basically a textual data. So wherever a textual data is there, you will see RNN in action. Okay. Next thing is, what is LSTM? Okay, I'm covering a few things in brief only. I'm not going in too deep. Okay. So LSTMs are long short-term memory. This is basically an RNN type architecture, or you can say a type of RNN. Okay. Sure. I'll send. So what is basically an LSTM? So this is basically an RNN type of architecture, and this actually overcomes a few things which are actually RNN has. Okay, a few limitations and a few problems what an RNN has. Those are actually overcome by these LSTMs, and this LSTM is basically developed by Hochreiter and Schumitzhug. Okay, he's Strumidhuber, we can say. Okay, I think it's a Swedish name, I guess. Yeah, so it's in 1997. So this is the problem of RNNs. Okay, so this was the biggest problem in RNN, which was overcome by the LSTM. Okay, there is something called as a vanishing gradient. Okay, so this vanishing gradient is the issue when uh, you know a particular function is computed and its derivative is instead of converging to a certain value, it is going to become zero, which is should not occur. Okay, so if that is the case, it is basically called as a vanishing gradient problem. So normal RNNs had this problem. So to overcome this only, the concept of LSTMs have actually come into the picture. Okay, so these LSTMs perform much better compared to that of the RNNs. So here you can see probably a few people might be aware. You have seen this, dou L by dou W, right? So it is actually dou. It's called as a dou. It's called as a partial derivative. Okay. Probably some might be knowing. Okay, so if you're from mathematical background, definitely you'll be knowing the partial derivatives. You have full derivatives, okay, or we can say derivation, and we have partial derivatives. So this is basically a partial derivative. Okay. So next thing is, what is a bidirectional LSTM? Okay. So if you are a non-math student, don't think too much. Okay. So I'll tell you in a very simple way. If you are a non-math student, I'll not tell you in a mathematical language. So according to math, I will use, but I will not tell you in math. Okay. I'll try to, change the, thing. To fastly train, okay, and things to happen in a faster way, you need a particular function which we are training the data on. That particular function has to converge. So converge in the sense it has to go to a certain value. Instead of that certain value, if it goes to 0, okay, so that means there is an issue. Okay, so that issue usually was actually happening in RNNs. Okay, so because of that only, the concept of LSTMs have come into the picture. Okay, so next is what is a bidirectional LSTM? Okay, so bidirectional LSTM is actually a form of LSTM, but this bidirectional LSTM is an advanced, I would say, advanced high-end model, if you say, or a high-end model of an LSTM, because this is actually doing more, or it does things more compared to that of a regular LSTM. Okay, compared to a regular LSTM, this actually performs in a much better way. Okay, so it performs actually in a much better way. Now, if you see the the forward and the backward directions, it is going to do. That is why this is basically called as a bidirectional. So that's why it is basically called as a bidirectional. So why use a bidirectional LSTM? Okay, so while a regular LSTM processes the input sequence, this bidirectional happens in both the directions, because LSTM usually performs in the forward direction. So, but this bidirectional LSTMs changed the nature and changed the fate, I would say, of a normal LSTM. So, what these things have actually made is it has started doing from both the directions. That means doing the forward pass and the backward pass. So, because of this, what has actually happened is the processing was much faster, okay, compared to a normal, process. Okay. So next thing, what are the use cases of this is basically, NER and parts of speech tagging, text classification, machine translation. So you have probably seen all these things, right? Next thing is the architecture. So forward direction, and it also happens in the bidirectional LSTM also, backward as well as the forward. Now let us see what is an attention mechanism. Okay, so let us understand that what is this attention mechanism. And we have a model which is called as a sequence to sequence model. Okay, and how this attention mechanism is, is going to be useful into the real modern day world, we will see. So this model, attention mechanism, especially in the sequence to sequence model, allows the decoder to selectively focus on parts of the input sequence during the decoding part. So rather than compressing the entire sequence into a single vector, as it is a vanilla encoder decoder model. So why attention? So why attention? We are saying it as attention is it can hold longer inputs, okay, or longer contexts in memory without the loss of the context. Yes. Okay. So the context will be kept in memory without the loss of that particular context. So, it is easy for the model to train because the context is kept in the memory. So because of that, it is called as an attention. Based on this only, the advanced version of this only is the transformer. So right from the attention mechanism, what they have made is the self-attention. So that is the upper model or the upper end model of a normal sequence to sequence model. They have built a transformer which is actually even more capable of building attention, which is also doing the self-attention part. This is the whole scenario. So basically, attention solved this by creating dynamic context vectors for each output step based on a weighted combination of encoder hidden states. This is the whole picture. Next, how this actually works. Okay, how this attention actually works. So let me take questions. Sure. I will share. Don't worry. Don't take too much tension. I will share. Okay. So here you can see that this is a step-by-step approach of how this attention actually works. Okay. Okay, so this is the process, and the first one is comparing the decoder's current state with all the encoder's hidden states. So compute the attention weights and how much as focus is given to each input. Okay, so that is why here, if you see the last line, I've highlighted in red because of that only, to see that this dynamic context vectors, which are important, it is going to remember as a weighted vector. So it is going to encode that, and it is going to keep in the memory of the hidden states. So on that basis only, here what is happening is it will focus on the inputs. It will give the attention. Now you can see that the weights to form a context vector. So this is basically a weighted sum of encoder states. So generating the output using the decoder state plus the context vector. Okay. So this is basically the formula. Okay. So formula, just for showing you guys, I have put. Okay. So no need to, by heart or panic. And this is how basically, the context vector actually performs. Okay. So each context vector will have an activation function. Okay. And each context vector having a activation function, and each one will have an attention. Okay. How much of attention is required, or how much of importance? Attention is nothing but importance. That's it on. So that importance is required. It is going to calculate the probabilities, and it is going to keep those probabilities, or we can say importance, in vectors. Actually, this will calculate by vectors. It is usually calculating probability only, but the importance will be shown as a vectors. So these vectors, how they're actually shared or stored in the memory. Okay, and how the attention is actually given is what the the concept is all about. Okay, so this is one more time. Now we'll go to this Bahdanow's attention tomorrow. Okay, so because in attention mechanism there are a few things which need to be discussed. So we'll go to that because that's a separate part. Okay, so based on these attention mechanism only, the new mechanism, which is the transformer, has actually been developed. So if you have any questions, you can probably ask me. Okay. So Harsh, yes, I can see a question. Sir, we are going to use activation function like sigmoid softmax. We will use, but not that much, because I will be only showing you a few parts which are very important, especially. We are going to cover transformer especially. I'm going to show you transformer. Probably you might not have learned about transformer, because usually they don't teach transformer in normal deep learning and AI class. Nobody teaches you actually. So that particular thing I'm going to concentrate. There are a few other things like Bahdanow's attention, and one more attention is also there. Long something will be there, his name. Very difficult to remember those. Those particular attentions I will focus upon. Okay. So I think this attention, I think probably you would not have learned, I guess. The regular things I'm not concentrating, which is very much linked to generative AI and agentic AI only I'm concentrating. So these things, what you are learning in your class, are basic deep learning. These AI agents, or the generative AI, is much more than the the deep learning part. Deep learning is only a 20-30% part of what these AI agents are capable of. They are much more they have transformed like a transformer. So what they have yeah. So they have evolved. So what you were telling, these all activation functions, everything is very important. And now this particular thing is just like a jujube for a for a transformer. So so it is like it has reached that particular height. And now we are also seeing the second generation transformer in action. In late 2024, they have launched the second generation transformer. Actually, NVIDIA has done a lot of research contribution to the second generation transformer. Rather than a regular I would say, rather than a normal transformer, which was actually developed by Google. So things went, things are, evolving. Something research they're doing, some, different things are being found. So especially they have targeted this transformer because this transformer architecture has a lot of potential. So they have identified that. So companies have identified that. So that is why what they're trying to do is they're trying to do a lot of research in the field of, transformer. So that is how things are, getting different, if you see. Okay. So let me just a minute. Give me a minute. I'll share this. Okay, give me a minute. I'll just share this. Okay. Yeah, day 10. So yeah, in the meanwhile, you can ask questions if you have. I'll share the PPT. Okay. So I've shared the PPT. Python files I've already shared. Okay. Yes. So questions. You can mark your attendance. Ma'am has shared. She's been sharing. Actually, you can mark it. All right. Please ask if you have. Fine, ma'am. We can wind up. That's like almost 9 anyway. Nobody's asking anything. I think they are fine. So yeah.
Yeah, thank you, sir.
Oh,
Uh,
you're okay. Yeah.
yeah.
Fine.
Thank you
Sorry.
for the informative session, and thank you everyone for attending. Let's conclude today's session here. We will
Sure.
see you on the next session.